Hey guys, how are you today? So today we're going to continue with our measurement of area, and today we're going to measure the area of another friend from our quadrilateral family, and that's the parallelogram. So the last time that we were together, we talked about how to measure the area of a rectangle. And you guys remember how you did that? Just by counting up all the squares that were on the surface. And I wonder if when you were working on the areas of the rectangle, you discovered the secret as to how to find how many squares were in the surface without counting them one by one. Did you discover that you could multiply the squares along the base with the squares along the height? Well, today we're going to continue looking at how to measure areas, okay? And like I said, we're going to measure the area of a parallelogram. So a rectangle is a type of parallelogram, but it's different because the angles are different, right? Now, the parallelogram has two acute angles and two obtuse angles, whereas the rectangle has four right angles. All right, that makes a difference because the parallelogram, when you look at it, doesn't have neatly arranged squares like the rectangle had, does it? So if I wanted to count up all the squares on my parallelogram, I really can't because there's a lot of incomplete squares on different parts of my figure. So how are we going to be able to measure the area if I can't count up all these squares? I'm going to tilt my screen so you can get a look at just the material. All right, so here I have the parallelogram, and I can't really see all of the squares that are on its surface. But I'm going to show you something. Okay, here I have another parallelogram. I have a congruent parallelogram because it's exactly the same as the other. And I'm going to put one on top of the other just to prove it to you. You see, these are two equal parallelograms. But I want you to focus here on this parallelogram. What happens if I rearrange it? Now what do I have? I have a rectangle. So this rectangle and this parallelogram must be equivalent because they have the same area, but when I have them arranged like this, they have a different figure. So if these two figures have the same area, what must be the area of my parallelogram? Remember how many square units my rectangle had? Okay, 50 square units. I have 10 squares along the base and 5 squares at my height, and 10 multiplied by 5 gives me 50. So my rectangle has 50 square units, and so does my parallelogram because these are equivalent figures. All right, so what does that mean? It means we can measure the area of a parallelogram and of a rectangle in the same way. Now, what you guys can do is you can make your own rectangles. Let me put my screen so you can see that. You guys can make your own rectangles, okay? And you can cut them up and rearrange them as parallelograms and vice versa to practice seeing how the rectangle is just a rearranged parallelogram and the parallelogram is a rearranged rectangle. That's it for today. See you next time.